The next talk by Felix Fischer. He is, of course, our head of data science and digital service. Naturally, he is an expert for planning, executing, and analyzing complex studies. Most prominently, he and his team are responsible for delivering numerical as well as visual output for all of our eye tracking studies. So naturally, as a research company specializing in eye tracking, we are interested in how empirically collected data, complicated words, compared to the quickly evolving splurge of predictive attention data. And Felix will share some insights with us.
Yes, thank you for the introduction. That saved me some time. Yes, I'm Felix from the Data Science and Data Service team, and we often get the question in the last years how to handle artificial-based, intelligence-based eye tracking data and heat maps. Usually these are heat maps. And yeah, we have focus on this. The question behind is a possibility to save some work by automated work. And the other question is a possibility to increase the quality of data. And so we have an eye on it since several years. And we also have researched it about it. But before, I wanted to start to show you a video, because a colleague said you have to show a video, that's good. And I will show twice in one. And let's go forward. Maybe. Yeah, okay. So it's not playing right now. I just want to say something about before. This is a video of browsing Netflix, and someone is changing the website. You will see there's someone doing with Builder.io some changes. And left there's a real eye tracking with real persons of it, and on the right side there's AI-based eye tracking. There's written SAI1. This is for specialized AI, which means it's an AI algorithm which is for eye tracking specialized. And we have two companies compared with real eye tracking. So this is SAI1, and later there will be also SAI2. It's very difficult to say it quick, sorry. You can try it later. Yeah, and now let's go forward with the video. Yeah, okay, now looks okay, but now there's I say the coding window opening, the white window. There's someone is writing something to change something to banana-related content, and it's just for fun, this to show what is possible, how easy it is to change something, but we did it now with eye tracking, and we see that people are interested about what the person is typing in, what is happening next, and what is the change. And the right one, it's not really reacting to it. It seems not to be interesting, the white window. This is maybe close to the humans, because usually if I see HTML code or something on a website, I'm not interested in. But in this case, it's interesting for people. Usually they want to see what's happening, what is the change. And yeah, there's a difference, but just an example. And we will show later that AI-based eye tracking is getting better. But next, I want to show another example. It's maybe someone of you already have seen it. Oh, no, that's the wrong direction. Oh, no, yeah, that's the right one. Yeah, maybe someone already has seen it. It's an example Michael often shows also to explain what's AI doing and what real humans are looking at. And yeah, it's I like this example very much because it's showing the pyramids. Yeah, maybe the most famous or one of the most famous buildings in the world. Everybody in the room knows about it. And everybody has somehow maybe also a little emotional relation to it. There are dungeons, there are the mummies, the pharaohs has been there. And also here's the Indiana Jones was there with his head more than one time. So it's very interesting for human to look at the pyramids. And AI, it's an older example, says, no, it's not interesting, I'm not impressed, or it's not interesting for humans. And in front, there's a mosque This is also a hotspot on the heat map. It's something, a special building people build for do something nice, and it gets attention, not at the artificial eye tracking. And let's see. Yeah. Okay. But AI attention predictions are getting better, much better, and I want to show, yeah, not much better, but better. And I want to show how the development is. And there's an example. Yes, this is one algorithm we used in 2022 and also in 2025. And it shows on the top, it's an advertisement. It's a part of a commercial about dog food. And the dog didn't get attention, predicted attention in 2022. But the dogs, two dogs, and there's one on the package and one who's eating the food. And now both dogs are getting attention in this algorithm, which is pretty good because it was a big fail 3 years ago, and now it's better. Lower, we have an example also from commercial video spot from M&Ms, and get the problem. Usually people, normal humans are looking on the M&M in the hand of the M&M because it's shown to everybody and everybody is looking at it's a small M&M. But 3 years ago, there was no attention predicted, and now it's still the same. So it's getting better. Not everything is getting better, but yeah, just to give you a feeling about. And so this is another example. No, sorry, it's jumping through and through. I did something wrong. Maybe. Okay, yeah, this is an example from we saw already from the SIA1, the pet food on the left, and on the right is another, and it's for the last 3 seconds. This is a matrix which is often offered by companies who are offering this kind of eye tracking, predicted eye tracking. And we see a big difference between the outputs. The right one says text is very interesting, which is not always wrong, because if you look at the advertisement after some time, you will start reading text, but it looks quite strange after 3 to 5 seconds that everybody's only reading. And we have the same on the right at the bottom, and that people are reading the M for a very long time. So it's not perfect, and yeah. And yeah, this is so a bit explorational. You see something, you say, it's good or not. And we wanted to get it more in a system. And that's why we decided to create a survey about the quality of predicted eye tracking. 1 year ago, there was the first QOPA. It's a quality of predicted attention. And yeah, jumping forward, thank you. Yeah, the result was, I don't want to explain too much now. It was, we had real eye tracking data, heat maps, and heat maps artificial eye tracking heat maps, and we compared them, and experts has to look on them and say, okay, the artificial eye tracking is close or not close to the real eye tracking. And we had a score from 56%, what is not very bad, but also not good or very good. But it's something you can maybe work with. And this was last year. And we did the QOPA again this year. And I will show you some stimuli now from this research, which were evaluated by experts and with 5 experts. And yeah, thank you. Yeah, we had this commercial, for example. It's a very old one, and we took it just to have something different, maybe. Nothing is trained on or so, special for this kind. But yeah, we have the first AI has quite similar results. It's a very good prediction in the middle compared to the left, to the real eye tracking. So I think experts would quote this with 90% or something. It's a very, very good one. On the right side, you have one which is not completely wrong, because there's a hotspot on the girl's face and also on the product as in the reality, and also as on SII1. but there's a big difference, and this is also a problem we will see later again and again. If you don't have the truth, we don't know which one is the better one, or how good is the predicted eye tracking. It could be a very good eye tracking, predicted eye tracking, but maybe it's very bad eye tracking, and so this is a general problem because there are big differences often. And this is another print that we analyzed. It's about the Mini, and it's about the first attention now, and we see the iconic car gets some attention, everybody knows, or nearly everybody will know, and the headline seems to be sensible. The first algorithm says there's attention on the headline, but no attention on the Mini. Yeah, it's strange. And the next one says there's almost no attention at the headline, but attention on the Mini. And this is a problem again. Sometimes it matches, sometimes matches about 50%. Yeah. And we also made this for full time. And there we have the real eye tracking, which shows it spreads the attention after the initial attention on the eye catcher, the red car, and also the new Mini model gets attention, the black one. And yeah, seems to be okay. It's okay, the advertisement. Maybe it could be better, but it's okay, I think. The artificial eye tracking one says there's almost no attention on the red Mini, what is very strange because this is eye catcher, and yeah, I think it's not realistic. But there's some attention on the black Mini, this is good, and also on the headline, and also some on the logo, what is important for the advertiser, of course. And the right one has now, again, a lot of attention on the Mini, some at the headline, but almost no on the new Mini, and this is a problem because this is what the advertisement is for the black new car. And if you take this algorithm, it would say, please change the color of the car in the advertisement or make the background different. And yeah, this is a problem. I guess the agency who created this ad was thinking something about it. And of course, there's not a high salience between the black Mini and the background and this, but maybe this is what they want. They want that someone is discovering the car in an abandoned area, the black car, black or dark background, and the whole story, which is maybe behind, is lost. The algorithm would say, no, it's not working, and maybe it's working. I don't know what was the intention of. Yeah, okay, and then we had. We had dogs, and okay, there's a cat coming. This is for cat food for the German advertisement from Whiskas, and the first attention says attention on the key visual and on the claim headline. Oh, sorry, no, and the first attention at the other at the artificial algorithm eye tracking. Looks quite good, I would say. That's a good example that it can work good. But we also made it for the whole time. Oh, sorry. Thank you. And the total attention now shows that after the initial attention on the key visual and on the claim, people are looking also on the product and also on the food on the plate and the little text which is there, another claim. And this would say, okay, it's okay as an advertisement. Maybe not the best one, but it's working good for now. And the first algorithm says almost the same. I think it's working good. I think this would be also be rated pretty good by the experts at the QOPA rating. And the other one is far away. And again, big problem because maybe what's the most important is the intention on the product or not. Yeah, there's no attention predicted. And so it's dangerous, to work with it. And forward, we did also use a generative AI just for playing. I just wanted to show quickly. It's something like ChatGPT or so. We have good attention on the car here, but very strange hotspot here. I don't know what it is. But you can get also heat maps, and heat maps are not looking bad or something, but maybe not that correct. The one cat food is pretty good, I would say, but did it twice, and another time it looked different. Was very strange, but yeah, it's somehow okay. It's one time very good, and yeah, and as the other one, there's just one plausible hotspot. And yeah, maybe the key problems which AI has to face as it wants to predict eye tracking is context, demographics. Usually you can't say, imagine you're a woman or you're a man, you're 20 years old or you're 40 years plus or something, and make me an eye tracking. Usually it's just in general way to get, you say, I want eye tracking on this, but not the demographic informations behind usually, and also not the context is as imagine your dog has birthday and you want to buy something very special for your dog, then you will look different maybe, and usually this is not possible. And motion sometimes, sometimes motion is a problem to detect. Maybe it's not a big weakness. Contrast salience, we had it with a mini, with a black background or a dark background. Still, the algorithm seems to be based a lot also on salience. If something is quite good visible, this is not wrong to be based on this, but it's not always the best way, especially if you don't have high contrast. Sometimes it's wanted to have a high contrast and not to have a low contrast. And yeah, complexity. Yeah, sometimes I think the AI is not getting the whole message of a commercial, and that's why the predictive eye tracking is maybe different and it's orientated on there's a face and there's something else. And this is the next point already also that the AI is maybe sometimes, I guess now the pyramids will, I have to check, maybe now it will detect the pyramids, but it's very human focused in a special way, human focused, that human faces are very important, for example, but also maybe pyramids not so important and other things. And this maybe are the things where AI should get better, but often they have good predictions. And now we have the result finally, and we did the QUOPA again this year. This, for example, the ads I showed. And we had now a score. We had 2 more experts and 2 specialized AIs now, as I mentioned before. And the QUOPA now is at 6.25 and 62%. This is the average score of the how good predicted eye tracking is, if our experts rate it. Yeah, so it's okay. It's a good reason to say, okay, development is good and you can play with it. Feel free. I would say, yeah, of course, just play with it and don't worry. But maybe be carefully with it, because there's a high difference between good predicted eye tracking and not so good predicted eye tracking. And if you know before, and which is how good is it? It's very dangerous to take. You can't say I take it and it will be about a probability of 60%. Could be much better or much less good. And yeah, and so the Sandbox we already presented today is a good way. Maybe use AI for making creations, and then test the creations with real eye tracking with the Sandbox, for example. So you can save money by creating maybe, and then you can see how but still test it with real eye tracking is I would recommend. And yeah, this is almost everything. Yeah, there's also Michael has a discussion on artificial intelligence and the wisdom of the heart. It's a bit close related to this thing, and I just wanted to make it public here. If you want to take part or hear it somehow, please reach out for Michael. Yes, and I think, yeah, that's it for now.
Thank you so much, Felix. Are there any questions from the audience?